Today we will be talking about the singleton design pattern. We will create a singleton implementation using C++ under Linux. So let's get started. So I will be creating a directory for the singleton. Let's say singleton, right? Here. So I'm going to enter that directory, and oops, I have a bad keyboard layout, so I usually make mistakes there. Here. So anyways, so we are inside the singleton directory. We don't have any files there, so I'm going to create a main file which will be calling our singleton implementation. I will be creating another file called singleton h, and I will be creating a singleton cpp file for the implementation itself. Now we can use an IDE or a text editor of your choice. It doesn't matter. For me, I'm using Visual Studio Code. I very like this editor. It's very flexible, it's very powerful, but feel free to use whatever you want. So I'm going to open the singleton folder, and as you can see, I have already the files presented here. So in this file, I'm going to include the IO stream for cout and endl. I will be using cout. I will be using endl, and I can implement the main function. I usually use the standard convention, which is including the argc and argv parameters, just because I'm a nasty bureaucrat, but feel free to ignore that if you want. Usually it will be 0 for success. I will output something like hello singleton. Okay, and just let's try to see whether this thing is okay. So I will create a binary directory. Alright, so yeah, so now I'm going to compile what I have, which is main cpp, and I'm going to output that into the binary directory with the main singleton. Okay, so it seems we don't have any problems. I'm going to enter the binary directory here, and we have our executable, which is singleton, and here you can see it works. So it prints hello singleton, so which means this skeleton is functional. Right, now why do you want to use a singleton? The design pattern of singleton is used mainly in cases where you want only one instance of your class to be available at any time, which means you have the class declaration and implementation, but you let the client user to instantiate only one instance of that class. Why? Because in some cases you don't want the client to be able to use more than one instance. For example, if you have a wizard that is responsible for opening a database connection, or if you have, for example, a graphical user interface wizard that is responsible for setting something, okay, for example, setting your graphic card, Okay, you don't want, or you don't have the need to, or it doesn't make sense of opening more than one instance of such an application. Okay, you on your machine you need only one such wizard that will touch the settings of your graphics card, or that will open a certain database, or that will manage your internet connections. Okay, so in that case the singleton is a useful implementation for such tasks. All right, so how we do implement the singleton. Basically you do the following. You create a static variable, a static data member of your class, and you create a static method that will return to the user a reference to that static variable. And you make the constructor private, so that no one else can instantiate an instance of that class. So we will see. So for example, I will put the guards here. Let's say singleton h define singleton h and if. Right. So class singleton. Oh, come on, not that. Singleton. Okay. And I will make this singleton constructor private. I will put a static variable of the singleton. I will call it S. It's a convention, we usually call it S. Now what? You can put any data member of your liking. For example, let's define, let's include string, for example. Okay, so let me put std string here and call it boss, or yeah, small boss. Okay, so now I will define the public interface. In this case you need to disable, sometimes, not always, but in this case you need to disable the copy constructor, which means singleton const singleton reference cause delete. Delete is the C++11 keyword. Usually before that we used to put the copy constructor inside the private section without the delete word, like this. We said this. We put that here without any implementation, and that would disallow or disable the copy constructor. The same for the assignment operator. But in C++11 we simply tell the compiler with the delete keyword that it shouldn't implement a version of his own, or we do not want to implement the copy constructor. Same goes for the assignment operator. Okay, so Singleton will tell the compiler that we don't want that. Right, now we implement the destructor, which is doing nothing, and we will implement a static function or static method that we call it by convention get instance. It will return a singleton instance, the only singleton instance that we will have, which is get instance. Okay, now since we have a data member here, then we probably need to do something about that. For example, a setter and a getter. So let me implement a setter here, set boss, and put a const instead the string there. Okay, and a std string okay, yeah, I'll leave it like this. Get boss. I don't care now about the temporary variables that will be created here in this case, because it's not the point of the video. The point is the implementation of a singleton, so ignore that for the moment. Okay, and now we go to the implementation itself and we include the file. Okay, so what do we have? We have the singleton. Okay, and we have nothing here. Also, since we have a static member variable, then we need to initialize that. So singleton s, that's it. Okay, so in this case probably we need to initialize the member variable. So sorry, so boss will be what? Who's your boss? Let's say Elon. Well, what was Elon Musk? Okay, I hope I was. Yeah, I don't remember if it's Musk or Mask. Yeah, Musk. Okay, never mind. So the singleton destructor does nothing in this case. And what else? Okay, so we have this singleton get instance, which in this case will simply return s. This is one of the implementations of the singleton. I will talk about other implementations in a bit. Now, so void singleton set boss const string, actually string, st, and I'm going to say boss equals st, and instead of string singleton get boss return boss. Okay, everything okay at this moment. We'll see. So now what I'm going to do is this. I'm going to include the Singleton header, and after that, alright, here's the fun part. Now I can call the instance of the Singleton, okay, the only instance that I have, by calling the getInstance method. Now when I call this method, it will return me the static variable s of the Singleton class. So if I want to change any properties there, to change the state of that instance, it's enough to call this member variable by the getInstance method, and after that we can set the properties that we want. For example, we can call set boss and say it's Bill Gates, for example. Okay. Before I do that, I will do something else. So I'm calling the instance, and I'm going to show you get boss. Okay. I'm going to do that by outputting boss is. So here we go. Alright, so I'm going to show you the boss first, and after that I'm going to change that. Alright, so let me say here. So I think I'm almost done. Let me check this. Yeah, I am. Singleton is okay. Yeah, I have an error. Okay. So it seems that I'm almost finished. So let's try it. Okay. Singleton CPP. Okay, expect initializer before boss. What? That was where? Singleton 6. CPP 6. Yeah. Damn it. You know, things happen. Okay. Alright, so it works. Now I'm going to the bin directory. Okay. And I'm going to call the guy and see what will happen. Alright, so first here you see. First I print the hello Singleton. After that I check who is the current boss, which is Elon Musk at this moment. Then I change the boss to Bill Gates by calling the get instance, and after calling the get instance of the Singleton, I set the method of set boss. Okay, and again I print the output, which is Bill Gates. As you can see, you can have your instance, one and only instance, change its properties and go continue doing your stuff. Okay, so this is one type of application of the Singleton. There are other ways, other implementations of the Singleton. For example, the initialization on demand, for example. How does that work? Okay, so first off, you don't need that. You don't need this, and yeah, you don't need that. And instead of that, in the get instance, you declare a static variable of singleton, which is called s, and you return that. Okay, so let's try this. Oops. Yeah, true. So in here you need to comment this out. Alright, so the program compiles. Let's try it again. Okay, it works. So what happened here? The difference is the previous implementation will create an instance of the singleton on program launch, on first run of the program. Okay, you probably not always want this to happen. You probably want the singleton to be created once you demand it actually. Okay, and you demand that actually when you call this function first time. The first time you call get instance, at that moment, at that very moment, okay, you will create your singleton instance and return it to the user. Okay, so if I'm not mistaken, I think this implementation was suggested by Scott Myers. He's one of the C++ kings, I'd say. So this was one of the implementations of the singleton. Okay, so either you create a static data member of a singleton inside your class, and then you return that data member using the get instance method, or instead of that, you create a static variable inside the get instance itself. Okay, again, this singleton will be alive until your program exits. Okay, so this is it acts as a global variable. Okay, it still exists in the memory until your program finishes and go out. This could cause problems or may not. Depends on your application and depends on how good you implement that application. There are other implementations of the singleton. For example, I think I've encountered one of the famous implementations, which is this. You declare your static variable as a pointer. So actually, let me see. I think this like this. So get instance, yeah, it functions like this. If not s, which means if s is not a null pointer, then oops, s equals new singleton, and yep, so I think that's it. Yeah, you declare your static variable of the singleton as a pointer to that, as a pointer to the class, and you initialize it only on demand. So when the user calls get instance, you check whether you have that variable initialized or not. If it is not initialized, you initialize it by allocating a chunk of memory for the variable, and you return the variable, the data member. Okay, so after that, when you want to call it, you use the pointer syntax like this. Okay, so for example, like this, singleton with instance, etc. So let's check what's happening here. Static singleton, blah 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 blah. Get instance, return static. Say what? Get instance pointer to static singleton. Yeah, so what? Oh yeah, I think I know. Yeah, here. Okay. Oops. Of course, I forgot also to delete the singleton. So here in the destructor, you also have to check whether your singleton variable exists or not. In case it exists, in case it's still a valid pointer, you need to delete it. Delete s equals null pointer. Okay. Before C++11 you would say s equals null or equals 0, but after C++11 there is a special expression called null pointer, and you use that. Okay, so if s, delete s equals null pointer, and that's it. Okay, yeah, I think that's it. Alright, so let's try again. Oops. Function here, undefined, singleton s. Whose reference is singleton s? Find reference singleton s. What did I do? Singleton. Yeah. Yeah, true. This guy should be initialized as well. Okay. So, come on. Conflict in declaration. Singleton s. Yeah, it's a pointer, damn it. Okay. Yeah, I think so. Yeah. Right. So now it works. Let's see if it works without problems. Yeah. So as you see, the same as previously, but with pointer notation and with initialization upon demand, which goes here. If we demand that, if we demand the instance, then we first check if it is a valid pointer. If not, we initialize it, we allocate memory for that, and after that we return it. After we finish using the singleton, we check whether it's the instance is still valid or not. If yes, we delete it and we set it to null pointer. So again, you keep using the singleton as long as you want, and after that it goes away when your program finishes, when your program exits. And that, I think, concludes this video tutorial. I hope it was useful for you, and see you next time.